Hello everyone, this is Aman, and we are talking about real-time and safety critical systems and how formal methods is incorporated into these systems. The article that I found was published by Airbus, which is a company that creates civilian aircraft, and they are using formal methods for validation and verification phases. So the question is, what is their goal by using formal methods? What are they trying to accomplish? So obviously the main goal is that it is a safety critical system, being aircrafts. They have to be safe and they have to make sure that there are no defects or errors in the system beforehand. Because if there are any errors, then there's some life at danger. But is there a secondary benefit? And the answer is yes. There's a lot of cost and time savings. This seems a bit counterintuitive because formal methods do take a long time, but we'll see how this is done. So this is the Airbus development cycle, and you can see it's split into 1, 2, and 3 levels. The first is the aircraft levels. So this includes the requirements, design, validation, and testing at the end, at the aircraft level. But the system level is what we're really interested in, and a little bit of equipment level. So the blue highlighted boxes are using formal methods. So the system requirements are written in formal methods language, and we'll go through the language a bit later. And the system specifications are written in a formal language. And the orange ones is an automated process. So because they are using formal methods in these blue phases, they are able to automate these phases, which is where the cost savings comes from. So these are the phases that help them with formal methods. So systems specified in a formal language helps them create automatic code. So they have to write less code. So if they have to write less code, they're able to create automated test cases because the code is generated by a machine. So the test cases can also be generated by a machine. And then they are also able to create the test oracle, which checks for if the code is valid or not, which also leads into automatic testing. So any code that is generated automatically from formal method specified information, they are able to test automatically. This is how the cost reduction happens. So before execution and after execution, it's done in 2 phases. Before they actually execute the code, they are able to detect any errors in the formal language, and they use model checking for that as well. So before they are able to even see the error, they can find it using formal languages. And after execution, obviously the cost reduction is in test case generation, test oracles, and actually testing the code. So everything being automatic becomes a lot easier. And one statistic that I found interesting in the article was that they only have 20% manual code that's being tested. This is a method that they use, static code verification, which is basically before execution, you read the code and they are able to unit proofs, which is per function in C language, which is what they use. And proof of absence of runtime errors, Stack Overflow errors, and various different errors they're able to detect before even executing the code. This is the language they use, SCADE language, and they use it for specification and defining the final state of the system and the Slarl-small strategy. And this is a small overview of the language. You have a variable and an expression, and variable, this means that the variable always equals to expression. And then you have this assert variable, which is assert Boolean expression, and Boolean expression is always true while the program is in execution. So it's kind of like an invariant, and pre-I means returns the previous value of I. The Slarl-small strategy is basically you test one piece of code, which is a really small code, maybe just one class. And if everything works, then you go to the second piece of code, which subsumes the first one. So it's kind of like a subset. The first one is the subset of the second one, and you keep moving until you come across the whole system and you're testing the whole system. So this is kind of like a flowchart. If it fails, then you repair the first system. If the second system fails, then you repair the second system. And these are the projects that they have in the works right now. Some things interesting are integration proofs. So there, we talked about integrating C functions by itself, but they are also trying to automate the integration of those functions together. And in conclusion, formal methods reduce a lot of time and cost for validation and verification. For Airbus, generate code from it, they're able to generate test cases, and they're able to test automatically. And this quote I found really interesting from the article that basically concludes it is combining formal verification and testing based on testing strategies will be the future of system validation and verification. And this is the source that I found. And if you have any questions, I'll be able to answer them. Thank you.